Okay, Jess, switch on. So they come back to us. When I first started teaching that, I used to teach this y equals 1 on x. And the annoying part when I teach it is 1 on x, it has this happen all over the place. The thing that mucks people up more than anything else, except for maybe negatives, is fractions. And then one day I went, no, don't do that. Let's make it nice. Let's make it a bigger number, like say, let's go 20 on x. 20 on x is not bad. Now, it says let x equal 0 and let y equal 0 for drawing graphs. Not for that one though. Because x never equals 0 and y never equals 0. So this is the weirdo one. Okay, on this one, we never get an x equal 0. What happens if we did get x equal 0? I'd have 20 divided by 0. So if I had let x equal 0, I'd have y equals 20 on 0, which does not exist. You okay? So we've got the problem. We need another method. Starts with S and it's got lots of letters.
Substitution.
There's no way around it. We can't do anything around. I'm not even going to. Look, there's a sketch again. I'm going to call that 20. I'm going to call that 20. I'm going to call that minus 20. Call that 20, and let's go minus 20 down there. I could go and draw it as a set of tables. I'm going to not draw it as a set of tables for a moment. So come back to me. If I said I'm going to let x equals 1, and I'm going to deliberately do different to what I've taught all my life. If I put a 1 into there, what do I get? Replace the x by 1, and what do I get as an answer? Everyone says 20, hopefully. How many ones go on the 20? So ready? I'm going to go over 1, there's 10, there's 5, I'm going to 1 and 20, I've got a dot there somewhere. What happens if I put in 2? And deliberately not draw up a set of tables. Replace the x by 2, what do I get? Everyone hopefully says 10. So I'm going to go to 2, and I come up to 10, which is about there somewhere. Another one. Would I use 3? Let's do it. If I put 3 in there, what have I got for y? And I'm going to write it this way. The answer is 20 on 3. And my brain goes, yucky. Could I draw it? What about 4? Let's make x equal 4, and what do I get as an answer? 20 on 4 is? 20 on 4 is 5. So now I've got 4, 5. So I go 4 and I come up here to about 5. I'm about there somewhere. 5 would be okay. X is 5. What do I get this time? 4. Are you getting quick enough with it to do it without me writing everything down? Will I bother with 6? Yucky. Will I bother with 7? Yucky. 8? No. Not bad if you had to. Thank you. 9? No. Get really yucky. 10! Yay! 10 works nice. 2. I'm down here somewhere. Will I bother with 11, 12, 13, 14, 15, 16, 17, 18, 19? No. I'm going to jump all the way to 20. 20 on 20 is 1. So there's our graph, sort of. Well, we've only looked at the right-hand section. How do you do the left-hand? Cam, you're okay there. We've only done the right-hand section. But what happens when you go further? What happens if I put in 40? I've got 20 over 40, which is half. So if I went all the way out to 40, there's 20, so about there's 40. It's coming down to a half. What if I go out to 80? I got 20 over 80. So what's that? So I go out to 80, and then I get a quarter. Get the message? So what's the graph doing? Coming down like this, goes like that, and it goes closer and closer and closer to the x-axis. So what do we put on the x-axis to say it gets closer and closer to it? Do you remember from last year? Dotted line. And the dotted line is called an A-S-Y-M-P. Yes. I need you to focus a bit more. Asymptote. Yeah? What about going up this way? It does the same. So it's got another asymptote that comes down there. Put the lid on. Asymptote that goes down there. What happens on the other side? The same thing, but instead of going upwards, it goes downward. So can you imagine if I did this with 1 on x? Every answer you get would be a fraction except for 1, 1. And one day it dawned on me that 20 worked better. I used to use 12 sometimes. And I went, nah. I used to use 10, and I went to 12, and I went to 20. So let's go to the other side. If I go x is minus 1, what's y become? 20 on minus 1. How many times minus 1 go on 20? Minus 20. So that's down there. At that point in time, do you get the message? Yeah. Probably put in minus 5, and I go 20 on minus 5. What's 20 on minus 5? Negative 4. So I went minus 5, and I go down to minus 4, which is about there somewhere. You probably get the message, and you just go, I got one of those there. Yeah? What are people doing instead? One last thing, come back to me for a second. Instead of doing all that, every person, I can still remember doing this about year 8 or 9, everyone draws up a set of tables. A table about a set of tables. That's not a set of tables. And we know that naught had no answer. How do we say it had no answer? Does not exist. How do you calculate it? Y equals 20 over 0. And 20 over 0 does not exist. And then people will put in 1, put in 2, put in 3, put in 4, and usually come stuck. So if you start here somewhere in the middle, because we know we're going to do minus 1s. And by the way, would I put 3? No. I'll go 4, and I'd go 5, and I'd go 10. Yeah? Question's done. So, now going through, oh, you don't need to, do you? Yes, you do. What happens though if I do this to you? Y equals 20 on x plus 5. What's it do to the whole graph? Every answer that we had for that graph has 5 added to it. So every answer we had for that graph gets an extra 5. So if I got an extra 5 centimetres, just made like that, have I got enough in me to get 5 centimetres? So does it change the shape? Does it move it sideways? Where does it move it? Up by 5. What if I went minus 15? I can do that easy. I might get there when I get older. I'm not going to shrink that much. My dad shrunk about 3-4 centimetres. He went from being that much taller to being a little bit shorter. One day I noticed he was shorter than me. So, you right? What happens to the graph though if I do this to you? What if I go 20 on x minus 3? So 20 on x plus 5 moves what? Up 5. Let's write the proper words. Translates. I could say vertically by 5. Now I want to have a guess what the last one is. This one is? Which way? Is it going to go left or is it going to go right? And by the way, if you weren't sure, you put some numbers in and see what happens, which is back to substitution. Last bit, some of you switch off, you're gone, I've talked too long. Does it move it left or does it move it right? So ready? Let's do a table. Let's see what we get. So what did the original table have? The 1 was a 20, the 2 was a 10, the 4 was a 5, that was a 4, and the 10 was a 2. Let's forget about the negatives. I got an x and a y, and I'm using this one. Let's put in a 1. I now have 20 on 1 minus 3. What's that? I'm breaking my rules, guys, I've been talking too long. 20 on minus 2, which is minus 10. So over here 1 was a 20, but over here 1 was a minus 10. Let's jump right over here somewhere. Let's go say 5. Let's not go 5. What would be better than 5? 7 might be good. We've got 20 over 7 minus 3, which is 20 over 4, which is 5. So 7 gave us a 5, but over here 4 gave us a 5. So the original 4 gave us an answer of 5. On the new one, 7 gave us an answer of 5. So did it move left 3 or did it move right 3? Some of you go, I don't know. What was the original? 4 gave us a 5. 1, 2, 3, 4 gave us a 1, 2, 3, 4, 5. That's there. Oops. There. That's the original. So that's for 20 on X. So what's the new one? That was 4 gave us a 5. 7 gives us a 5. 5, 6, 7. 7 gave us 5. Which direction did it go? So it meant right 3. So not because we want it to. When you put an x minus 3 in the bracket, because that line there means bracket, of course, fractional line means bracket, what did it do to the graph? Move the 3 to the right. That's why I say everything that's written on an inside does the opposite of what's expected. Enough said? Then you have a go at the exercise. A few questions I'll pick out.